Hey everyone, welcome back to our channel. Today we are going to solve one of the most popular coding interview problems, that is the threesome problem. It is there on LeetCode as well. So we will cover both the brute force as well as the optimized approach for this question. So make sure to watch till the end. So let's read the problem statement. So basically we have been given an integer array nums, okay. Then we have to return all the triplets, like it is given nums of I, comma nums of j, comma nums of k, such that I is not equals to j, I is not equals to k, and j is not equals to k. So basically this is the condition of uniqueness, right? Basically all the elements should be unique. And here one more condition is there, nums of I plus nums of j plus nums of k equal to 0. So the triplet we need to return is basically their sum should be equal to 0. Okay. So one more thing is there, like the solution set must not contain duplicate triplets. Okay. So let's understand it through an example given in the question itself. So basically we have been given a nums array, and this is the inputs elements. Basically the output we are getting is -5, -1, 2, and -1, 0, 1. So basically what it is happening here is basically like these are the triplets we wanted to return as given in the question. So as an output we have wanted to return this. So how we have to take care of the constraints that it is given, like the uniqueness we have to follow, and the summation of the elements which are forming triplet should be 0. So here it is forming both the things, like in this array we can see -1, -1, 2 are the unique elements, and the summation will be like -2 plus 2 will be 0, and -1 plus 0 plus 1 will be 0. So let's go deep into the explanation part basically. So nums of 0 is plus nums of 1 plus nums of 2 is basically, we can see -1 plus 0 plus 1, that will give us 0. And here the nums of 1 plus nums of 2 plus nums of 4 will also give us 0 solution. And nums of 0 plus nums of 3 plus nums of 4 is equals to 0 itself. But here the distinct triplets are only -1, 0, 1 and -1, -1, 2. Okay, we will ignore this one because these are basically the duplicates. If we sort this, these are the duplicates. So the order of the output and the order of the triplets does not matter. And in the example 2 we can see, like if we have a smaller elements in an array like 0, 1, 1, so the only possible triplet does not sum up to 0 will be like empty array. So let's go to the explanation part, basically how we need to think the brute force solution first of all. So what should be the first approach to solve this question? Okay, so how we can do it? By, like, basically first of all we need to think very naive way. So we can get the triplets by simply checking every possible triplet that is out there in the array. And how we can do this? Basically iterating, traversing through loops. Okay, so let's understand it with the help of a table which I have given here. So basically how we will take it, let's take the example nums which was there in the example in the question itself. So how we need to think of it, basically in this table, how we are doing is like in the table itself we are having I, j and k. Okay, you all can see it here, and we are also having nums of I, nums of j, nums of k, and the sum and the triplets added or not, we have to decide it. So I will give you a row by row explanation in the dry run. So first of all I will make you aware with the columns that I used. So basically I, which is pointing to the first element of the triplet, okay, and j is basically pointing to the second element of the triplet. Similarly k will point to the third element of the triplet, right? And each row in the table shows a different triplet selected by I, j, k, and we will calculate their sum. So basically row of first in the first row we are having I is equals to 0, j is equals to 1 and k is equals to 2. Okay, so we have picked the triplet nums of I is equals to -1 and nums of j is equals to 0 and nums of k is equals to 1. So their sum will be very obvious, like it will be 0 only, and this is the triplet we need to return, and the triplet this will be added to our output. Similarly, in the row 2, we are having I is equals to 0, j is equals to 1, k is equals to 3, and we have picked the triplet nums of I is equals to -1, j is equals to 0, and nums of k is equals to 2. So sum, if we calculate the sum, we will get as -1 plus 0 plus 2, which we will get as 1. So sum is not 0, so we will discard this triplet. Then in the row 3, we are having I is equals to 0, j is equals to 2, k is equals to 3. So the picked triplet will be nums of I is equals to -1 and nums of j is equals to 1 and nums of k is equals to 2. Here also sum will not be equal to 0, as we can see this -1 plus 1 plus 2 is equals to 2. So we will again discard this and we will go to row 4. We are having I is equals to 1, j is equals to 3, k is equals to 4. The picked triplet will be nums of I is equals to 0 and nums of j is equals to 2, nums of k is equals to -1. Again, the sum will be 0 plus 2 plus -1 is equals to 1, which is not equal to 0. So we will again discard this. At row 5, we are having I is equals to 1, j is equals to 2, k is equals to 5. So the picked triplet will be nums of I is equals to -1 and nums of j is equals to -1. Okay, and nums of k is equals to 2. Here you all can see this, the sum will be -1 plus -1 plus 2 is equals to 0. Okay, so the triplet here the condition for the triplet is getting solved, like we have to return this as the sum is 0. So we will add this to our output. Okay, and at last the row 6, I is equals to 2, j is equals to 4, k is equals to 5. The picked triplet will be nums of I is equals to 1, nums of j is equals to -1, nums of k is equals to -4. The sum will not be equal to 0. That is, it is clear that 1 plus -1 plus -4 will give us -4. So we will discard it. So as we saw, like it is clear that the output triplets will be -1, -1, 2 and the -1, 0, 1. So let's go through the how we are going to solve this, basically how we have to code it into a solution. Basically two things are there in this. We have to for getting the 3 elements we need to use 3 for loops. Okay, so the after using 3 for loops, what is the problem is basically finding the unique triplets. So for ensuring uniqueness, basically what we can use the set data structure for ensuring the unique triplets. Let's go through the pseudo code here. Like for managing the sum condition, we have array of I plus array of I, j plus array of k, and if the condition if the sum equal to 0, then basically we are initiating the temp triplet, basically array of I, j and k, and we will sort it. Basically we will sort it because we have to insert that into a set for ensuring the uniqueness. And after that we will return the vector of vector set and set dot begin, set dot end. It is basically the answer which we wanted to get. So let's go to the code in simple way, brute force code, basically we can say. So we are using 3 for loops. We can see it is the for first element, for second element, and k is for the third element. And this is the condition, like if the nums of I plus j plus k is equal to 0, we are getting the triplet value, and we are sorting this triplet for ensuring the duplicacy, handling the duplicacy, and we are inserting them into the set. After that we are returning the vector of vector, the result which we wanted to get. So basically this approach is, what's the problem is basically like we are using 3 for loops which are nested loops, though. So the time complexity will be like O of n cube. Along with that, this is very slow, and the space complexity is also like O of k for storing unique triplets. Okay, so we need to think of a optimized approach for this. Like O of n cube is too much, so we will think of an optimized approach. So our approach should be like, by using 2 pointers technique, we can reduce the time complexity of the approach. So how we will do this, basically how we can think of it. So let's see what we can do. Let's move towards the optimized approach screen. Give me a second. Yes, so how we can solve it using the optimized approach? First of all, we will sort the array to handle the duplicates efficiently. Okay, and what we will do in the 2 pointers, like we will fix the first element nums of I, and we will use 2 pointers left and right to find the remaining 2 numbers that will sum up to 0. Okay, so what I'm trying to say is basically here you can see in this particular array we have fixed the pointers here, like and the first index and the last index and the middle of it. So how we are doing it, let's see. So after fixing the elements nums of I, and you use the 2 pointers left right to find the remaining 2 numbers that will sum up to 0, we will move the pointers accordingly. Like if the sum is greater than 0, we will move the right pointer left. Just listen to the conditions what I am telling. I will dry run for you and you will be able to get it very easily. So don't worry about it. So, and if the sum is greater than 0, move the right pointer left. And if the sum is less than 0, move the left pointer right. And if the sum is 0, store the triplet and move both pointers to avoid the duplicacy. Okay, so let's go through the table. What I am trying to tell you all is basically, let's go through the table how it is getting fixed. Here I will show you how it is getting. So we are getting the input array like -1 0 1 2 -1 4, and we will sort the array as I discussed in the first step. We will be doing sorting, so in order to handle the duplicacy. So if we sort it, the array will become like this, sorted array. So how we will be able to do how we will be doing this, basically sorting helps in efficiently finding the pairs using the 2 pointer. After sorting, we will be processing the elements one by one. So the I loop through the array, we will iterate through the array, okay, considering each element as a potential first element of a triplet. Getting my point? Okay, so using 2 pointers, basically left starts at I plus 1 and the right starts at last index. Okay, so we will check the sum of nums of I plus nums of left plus nums of right. So again, as I told you all, if the sum is less than 0, we will move the left forward and increase the sum. Okay, and if the sum is greater than 0, we will move the right backward, we will decrease the sum. And if the sum equal to 0, a valid triplet is found. That will be the answer. So let's go through the table and I will tell you all how is it happening, everything. So in the first iteration, I is equals to 0. Okay, and the nums of I is equals to -4. Left is equals to 1 and nums of 1 is equals to -1. Right is equals to 5. Nums of 5 is equals to 2. Okay, so the sum will be like -4 plus -1 plus 2 is equals to -3. So the sum is like less than 0. So we will move left to 2 to increase the sum. In the second iteration, what we have to do is basically I is equals to 1 and the nums of I is equals to -1. So left is equals to 2 and the nums of 2 is equals to -1. Right is equals to 5 and then the nums of 5 is equals to 2. So the sum will be like -1 plus -1 plus 2 is equals to 0. As we all can see, this is the required conditions completion and the triplet will be found. So -1 -1 2 will be the required triplet. So next we move left to 3 and right to 4 because in order to reduce the duplicacy. So again in the we have to continue with I is equals to 1. So nums of I is equals to -1, left is equals to 3 and nums of 3 is equals to 0. So we will move and right is equals to 4. So we will move nums of 4 is equals to 1. Sum will be like -1 plus 0 plus 1 is equals to 0. So again the triplet will be found -1 0 1. Again we will move left to 4, right to 3 and we will stop as left is greater than equal to right as mentioned in the input itself. Okay, so final output will be like the unique triplets we will get is basically -1 -1 2 and -1 0 1. So I hope you guys understand this dry run. I will also tell you about the how everything is happening through the code itself. So let's go to the LeetCode interface and I will tell you how all this is happening. Basically, we are having the function, and after this we are initiating the result in order to store vector of vector. It is basically vector of vector, and we are storing the unique triplets in it. Okay. Then our steps comes like I have explained it very deeply here. We will first of all sort the array to easily handle duplicates, and here we will use two pointers. After that, we will be iterating through the array, and we will write the if condition for avoiding duplicates elements for the first number. How we will do is basically if I is greater than 0 and the nums of I equal to nums of I minus 1. So basically, in order to tackle the duplicacy, we will use this condition and we will continue this. Okay, and in the steps itself, I told you all like if the for the second pointer that is left, we will initiate it as I plus 1, and the right is basically the last index. It is pointed towards last index, that is the third pointer, that will be n minus 1. And at the step 3, like what we have to do is basically we are using the two pointer approach to find pairs that sums to nums of I. So while left is less than right, basically we are calculating the sum, and if it is 0, the our required triplet found, and we will push back it to our result that we have declared over vector of vector. So basically after getting the triplet, we will ensure that the next time we are not getting in order to handle the duplicacy, we will move both the pointers, and in this way we will avoid the duplicates. Okay, so after doing this process, we will increment the left pointer, and we will decrement the right pointer as I told you in the dry run itself. And if the sum is less than 0, we will increase the sum by moving the left pointer and if the sum is greater than if the sum is greater than 0, we will decrease the sum by moving the right pointer backward. And after that, we will simply return the result as we get the required triplets. So let's come to the time and space complexity of this solution. Basically, this approach uses sorting plus two pointer technique, which will reduce the time complexity as compared to brute force approach. Okay. So in order so time complexity analysis will be like we are sorting the array, which will take O of n log n time, and if we iterate over the array, we are getting the time complexity as O of n, and if we are doing two pointer search, so which runs in O of n only, so final time complexity overall will be like O of n log n plus n square. So the equivalent time complexity will be like O of n square, which is better than the brute force approach, which was taking O of n cube time complexity. And space complexity will be like no extra space we have used. We store only the valid triplets in the result vector. In the worst case, the number of unique triplets will be like O of n. So final space complexity will be O of 1 only if we exclude the output storage which is required. So if you understood the solution, please hit the like and share button. Thank you.